Fine HVAC has a friendly, familiar user interface. In the program we can find all the classic CAD commands, but also the commands that are needed to make the drawing of our projects very easy and fast. In this series of videos we will see how to calculate the thermal losses, the cooling loads and the system that we will use in a 2-level residential building. The same procedure and method can be done with any type of building regardless its size and type. Very large projects can be simulated without any problem in the drawing or the calculations. First of all, a new project is created by giving its name. When we create a new project, a folder with the BLD format is created, and inside that folder, the DWG format drawing is placed. The folder and the drawing share the same name of the project. If we have some architectural designs, we can place them as external references. For that purpose, we can open the DWG file and edit them. By executing the command burst, the blocks are exploded and the text remain in the previous format. After that, the color of the drawing can be changed from the home menu. A new block can be created using the W-block command. We can select the base point of the drawing, a specified point that maybe is the same in every floor. After that, the entities will be selected and the path of the file will be given. We can save the file in the BLD folder of the project. The same procedure will be done for all the levels. The architectural design can be closed without saving the changes that have been made. In the project drawing, we can execute the building definition command from the definitions menu. With that command, we can define the levels of the building. In the window that opens, the name, elevation, height, and external reference of the level is filled in. By selecting Add Up, a new level is placed on the top. When the levels are defined, press OK to return on the drawing. As it is shown, the external references are placed in the same coordinates for both levels. Let's start the drawing of the building. First of all, the north direction must be placed. From the construction menu, we can see the typical options for the openings, walls, etc. By pressing that command, we can see the project data that we will use in the folder. A subset of the library is shown in order to be faster for the user to select a specified type of wall, etc. New options can be added from the library just by selecting the corresponding option. From the menu, Building Entities, we will draw the building. First of all, we will select the outer wall command. In the window that opens, the type, elevation, height, and thickness of the wall can be changed. Also, changes can be done on the beam and the thermal bridges. After the definition of those parameters, elect Accept and draw the wall. Select the first and last point of the wall, and the side that the wall will take thickness. After the first wall, we only need to select the last point and the side of the thickness. Very easily, all the external walls are defined. With the same steps, the inner walls will be created by selecting the command on the ribbon menu. In the majority of the cases, the thermal bridges and the beams are not placed in the inner walls. Select the window command. Here the user can select many parameters like the type, drawing, thermal bridges and other geometric parameters. In order to place the window, just select the wall, where it is going to be placed and the coordinates of the label. If we select a point wrong, we can change the length from the grips of the window. Just like that, all the windows can be drawn. The doors can be drawn with the relevant command. The use of the door command is the same with the window command. At any point, we can see useful tips for the use of the commands at the status line. Select the command placement to draw the columns. We can define the column by giving the dimensions or with points and polyline. Changes can be done for the thermal bridge, the type of the column and the shown hatch. The columns can be copied in the other places. The floor can very easily be drawn by giving the floor type and the points of the floor. The second floor can be drawn very easy as we drawn the first one. If the second floor was the same, we could use the copy building floor command from the definition menu. The Fine HVAC program offers many facilities to help the user draw faster. In the second floor, we can place the ceiling just like we have placed the floor before. On the first floor, part of the floor is in contact with the external environment, while another part faces an interior space. To design the area that is in contact with the external environment, we can activate the layer, Other Floors, below. This way, we can see the walls of the ground floor and easily design the floor. Now we need to place the shadows to finish the drawing. And the horizontal slab will be drawn from the corresponding command. We need to attach only the walls and the windows will be attached automatically. In the second floor, we do not have any other slabs. Now we have finished the drawing of the building entities, and we can proceed in the drawing calculation menu. First of all, we need to define the spaces. Select Space Definition by Point command, a point inside the space to define the internal space. Just like that, all the spaces on both levels can be created. With the command Cooling Surface Model, you can see on the 3D view all the entities that are going to be calculated on the thermal losses application. We can select Shade to see the entities with a color. That's a confirmation that all the entities are recognized and are going to be calculated. Fine 24 allows users to define building parameters related to thermal losses and cooling loads directly within the COND environment. By double-clicking on a space, you can define all the data that affect its thermal losses and cooling loads. First, we enter the ventilation data in the ventilation data field. We can use the auxiliary tables for the ventilation values. We must also enter these values in the thermal losses and cooling loads tabs. In the same way, we continue with the space data, people, equipment options, and lighting options tabs. With this process, we have defined all the data for a single space. To avoid repeating the same steps for the other spaces, we can simply copy the data from one space to another. We select the Copy Entity Formatting command, and then click on the space for which we have already defined the data. In the window that appears, we select the data we want to copy. For example, we deselect the equipment data if we do not want it to be copied. Afterwards, we select the spaces where we want to paste the copied data. As we can see, all the data is transferred except for the equipment data, which we deselect. As next, we can make changes to the data of each space individually. With the Thermal Losses command, and by selecting to update the drawing, the Thermal Losses application will open automatically. In the calculation program, we need to update the calculations from the drawing. At Project Info menu, we can write some information for the cover page of the printouts. The main project data menu is Building Parameters menu. There many parameters can be changed, such as the city, the temperatures, the calculation method, the increment, and a lot more. These parameters have already been defined in the Kant software, but changes can also be made within the calculation program. At the Structural Element menu, the typical elements are shown as we define them in the drawing. In the new version, we can add new building elements to the libraries and calculate the U-factor in detail based on the materials they consist of. For example, we navigate to Libraries, choose Outer Wall, and add a new wall. First, we enter the name and check the Detailed Calculation checkbox. Next, we click on Analysis, where a window opens allowing us to add the materials that compose the wall. The new wall has been saved in the program's library. To use it in our project, we simply go to Project Data, Structural Elements, and select the wall. The thermal loss calculations will then be based on the U-factor calculated for the new wall. The window, calculation sheet is the main window of the calculation program. There we can see all the structures, with the geometrical parameters, and the thermal losses. Moreover, in the bottom window, we can change some parameters like the air exchange per hour, the shield coefficient, the thermal bridges, etc. If we change the parameters in the calculation sheet, changes will occur only for the specified space. The same changes for all the building can be done from the building parameters, as we show previously. The program automatically produces some printouts. We can link those printouts on Word, Excel, or export them in PDF and RTF format. After that, we can return to the drawing to update the spaces from the thermal losses. With the cooling loads command, we can proceed to the calculation app. First, we need to select Update from Drawing. From the Project Data menu, we can make some basic changes like the indoor design condition, the building parameters, where we can change the calculation method, the safety factor, etc. In the calculation sheet, we can see all the surfaces, the shades, and the loads for every space. Also, we can make changes on the people, equipment, and lighting load with the use of ASHRAE tables. As we can see, the spaces on level 1 already have the data for people, load, etc., since these values were defined in the CONT software. With the right click inside the calculation sheet, more options are available, like some diagrams and loads. At last, we can link the printouts to Word just like we did in the thermal losses. So easily we can draw a building and find all the thermal losses and the cooling loads.